Welcome back to the Learn How to Use WonderLogix Studio training series. In this episode, we're going to continue building our water supply system. And now we're going to begin working on our first change order. So after running the system, the level transmitter occasionally gave us unreliable readings, and so that led to water overflowing from the tower. So if you remember in our earlier design, we were supposed to be monitoring the water level between 40 and 60% and turning the pump on if it was below 40, turning it off if it was over 60. But something about that level transmitter wasn't working right all the time, and so sometimes the pump just wouldn't shut off. So our proposed solution to fix this is that we're going to put in a level switch to be able to report when the water level is at a high point as an extra check so that we don't overflow the tank again. And while we're at it, we're going to go ahead and change those hard-coded level transmitter percentages to properties and parameters. And it's going to look something like this. There you go. Here's our updated drawing. And so you can see here that we're going to be working on changing these numbers to parameters and properties and introducing a new logic editor tool for you to use. And then we're also going to be creating this level switch high and updating our logic so that we can help prevent the tank from overflowing. Let's get started. Okay, so first we're going to change those numbers to parameters and a property, and there's modifications both in the water tank. So let's go into our water tank, double clicking. And first let's add a parameter here. So let's go add a parameter, call it minimum level. Okay, we're going to set that to be an analog type. So number, put that at 40%. And then now at this point, we could add another parameter, right? It would make sense to add another parameter called maximum level, set that to 60%, but we want to show you an additional tool down in the logic editor. So instead of just creating a maximum level directly as a parameter and setting it to 60, let's look at another method where we create our higher value, not based on a fixed number, but on an arithmetic difference. So in this case, we're going to add another parameter, and we're going to call this level difference. And we're going to set that to be 20. And then we're going to create a property. We're going to call this maximum level. Okay, and with this logic box here on maximum level, we're going to open that up and we're going to turn on this extra feature for the numeric modification. And so the numeric modification option allows us to change the sentence structure to say we want to make the maximum level equal to, and we could say absolute value here in this box. We could say the parameter, right? So minimum level or level difference, whatever we want to pick here. But notice there's now an enter calculation option. So this is a way that we can actually enter regular calculations. But for basic math, we can just go ahead and enter our parameter, say that the one that we want is the minimum level. And then the basic math that it opens up is that it allows us to say plus, minus, multiply, or divide by. So we're going to say the minimum level plus another parameter, the level difference. So make the maximum level equal to the parameter minimum level plus the parameter level difference. And instead of while, we'll just say always, right? We want this always to be true. So make the maximum level equal to the minimum level plus the level difference always. I'm going to accept that. Very good. And now we're going to update our filling required logic so that we make use of this new maximum level instead of these hard-coded values. So we're going to edit our reports filling. We're going to say that hit the pencil there to edit that line. The water tank report filling required from the moment the reading of the level transmitter is less than this parameter of minimum level, and accept that. And then to clear that, we're going to say the water tank clears it from the moment the reading of the level transmitter is greater than the property, the maximum level. And so in this case, the conflict resolver stays the same, and that finishes up our change here inside of the logic box. So here we are in the water tank. We're going to add another switch, which is over here in our classes already, so we can do that. Level switch high. I'm going to double click to put the tag from our drawing in there. LSH203. Save that. And notice it already has an output, right? Already has an output active. And we now need to update our filling required logic again, because now we want to say, hey, if it turns out that the reading of the level transmitter is not working right, this was our backup, right? We wanted to be sure that the level switch high, if it was active, would be able to keep the filling from happening. Go back and edit our logic again. And we're going to start with this one here with the pencil on the clear sentence, right? When do we want to clear this case, right? When do we want it to stop pumping? So we're going to click that to edit that, and we're going to say that the water tank clears filling required as soon as the level transmitter is greater than the maximum level. Or, this is our backup condition, the level switch high, I'm going to change this to is, level switch high is active, right? Because we want to stop in that case. Now this does stop the pump from pumping if the water were to reach that level switch high sensor, but let's also prevent it from starting to fill if that sensor is active as well. If for some reason it thinks that the water levels drop below 40%, but the water is actually at the high level from the level switch high, then we certainly don't want to start pumping. So now we're going to edit our report sentence, and we're going to say that filling is required as soon as we drop below the minimum level and the level switch high is not active, right? So we want that to be not active in order to be able to fill. And with that, we have now completed our change order number 1. And in our next and last episode, we'll be adding our second change order, where the folks running the operation decided they'd like to have an external operation button so that we can be able to turn the power off without having to actually just go unplug things. And we also want an indicator light to know when there's been a failure so that we can tend to that as soon as possible. So we'll see you in the next episode.